B is created with value 25. Suppose if I create a variable like this, something like this, C, D, E. With this what happens? We have created 3 variables and we have not initialized this. So what happens? C is a variable, contains some garbage value. D is a variable, contains some garbage value. E is a variable, containing some garbage value. Suppose if I create a variable something like 2, 3, 4. Is this accepted? No, because a variable cannot start with a digit. A variable name cannot start with a digit. So this statement is not valid. So leaving this, if I create something like this, F is 5, G, H. With this what happens? We have created a variable named F with value 5. And what is G? G is another variable. G is another variable, H is another variable. These two variables are not initialized and this is initialized. So with this what happens? F is a variable with value 5. G is a variable containing some garbage value. H is another variable containing some other garbage value. Leave this. Suppose if I write something like this, int some I equal to 6, 7, 8. What system will understand from this? What system understands is I is a variable with value 6 and 7 is a variable, 8 is another variable. This is what system will assume. It's something like F is a variable initialized with 5, G is another variable, H is another variable. Like this, I is a variable initialized with 6 and this part is over. This is another variable. This has no relation with this one. This has no relation with this one. These two are also treated as variables. But can we start a variable with a digit? No, it's not possible. So this statement is also not valid. So problem with this statement is what? 7 and 8 are created as variables, but 7 and 8 are constants but not variables. So that statement is not valid. Suppose if you write something like this, int j equal to 6, 7, 8, but parentheses, something like this. If you write something like this, actually j is a variable that can hold only one value at a time. But what we have done here, 6, 7, 8 separated by commas and grouped as a single unit. So with this what happens, j should get only one value out of the 3. So which value will come into j? It will be 8. So when we write a set of values separated by commas but only one value should be taken, then the last value will be taken from you. So with this what happens, this 8 will come into j. So just system will check 6 and 7 but this will not be considered into j. So what we can get from this statement is j is a variable created with value 8. 6 and 7 are not taken into this. Then it's over. But what I want is, because whenever you give a set of values separated by commas within a set of parentheses, then what happens? Only one value will be taken. But what I want is, I want to store all the values into the variable. Suppose I want to store all the 3 values into this variable. In that case, what we should do? You do something like this. Int some k is 6, 7, 8. Suppose if you write something like this, what is the difference between the parenthesis and the curly braces is, consider all the values. Here, consider only one value. The parenthesis is consider only one value. Curly braces is consider all the values. So 6, 7 and 8 should be stored in k. Then is k is ready to store 3 values at a time? No, it's not possible. K is a normal variable and it cannot store 3 values at a time. So this statement, variable is okay, values are okay, but these two combination is not okay because k is a variable that can take only one value at a time. But we cannot store 3 values. With this, system will not accept this. This is also not valid. Suppose what I need to do, something I want to store 3 values into a single variable. Then what we should do is, we should provide something so that the variable will, because whenever you are creating a normal variable, only one location, means location to store one value will be allocated, memory. So if you do something like this, suppose int L, you just use square bracket set. This square bracket set is 6, 7, 8. With this what happens? With this square bracket along with the variable name, system assumes that this variable should be allocated with more memory. How much memory? It depends on these values we have specified here. Like 6, 7 and 8. Means what? L should be allocated with a place with memory that can accommodate 3 values at a time. So that system will allocate for L, it will allocate 3 locations at a time. Like this 3 locations is allocated. So 6, 7, 8 will be stored inside this. So here A, B, like C, F, J, all these variables are one type, normal variables. These variables can store only one value at a time, right? But L is a special variable compared to these things. This is a special variable. This can hold more than one values at a time. Now, I write a statement something like this. Int M is something like 13, 10, 9, 2, 17. Some values everywhere. With this, what system will understand? M is a special variable compared to these normal variables. This is a special variable, and this can hold more values at a time. How many values? These many values, like 1, 2, 3, 4, 5. These 5 values. Memory will be allocated for storing these 5 values. So it will be something like M is created with 13, 10, 9, 2, 17. This is what happens. See, these variables A, B, C, D, E, F, G, H, J, all these variables are normal variables, and these variables are arrays. L and M are arrays. Array is nothing but a set of elements. Simply, very simply, it's a set of elements. See here, L is holding 3 values. All the 3 are integers. Similarly, M is storing 5 values. All the values are integer values. That's why we have created these variables as integer type. And the square bracket indicates multiple values. This can hold multiple values. This is what happens. Suppose if I want to store a set of float values, means it should be able to hold fraction part values. In that case, what we will do? Just we'll take another variable here. Suppose if I go with int some n of, suppose instead, because we want to store float values, we just will go with float here. Float n of is something like some value, some random value there. With this, what happens? N is an array, like L and M. N is an array of float values. It can store how many values now? 4 values. So with this, what happens? The memory allocation will be something like N is allocated with 4 locations like 17.1, 87.2, 12.4, 19.6. This is what happens. So these two are called integer arrays. This is a float array. Right? This is float array. These two are integer arrays. Suppose I want to store a set of characters. Then what happens? I just can create something like character, some O or some P I am taking. P equal to small numbers. So with this, what happens? P is an array. P is a character array that is holding these 5 values. So with this, what happens? An array will be created that stores S, M, I, L, E. These are all characters, a set of characters. All name of this is P. P is the name of this character. So we have created 2 arrays of integers, 1 array of floats, 1 array of characters. So with this, what happens? Whatever the data we have specified, according to the number of data elements, the size will be decided. Right? So this array is what? A set of similar typed elements. So this is similar type elements like float values, here character values, this is integer values. But sometimes we need to create an array. But we don't know what are the values to be stored in advance. Because in these cases we are creating arrays with fixed known values. But sometimes we need to create an array that does not give any idea about values to be stored. In that case, what we can do is we just create an array. Suppose if you create something like this, int q of, we have written something like this, int q of. With this, what system can understand? Q is an array of integers. How many values? That we don't know. So Q system don't know how many values to store in this one. How much memory to allocate in this for this? Don't know. So with this system, this notation is not valid in C language. In C, we cannot do this kind of creation. So with this what happens? System don't know how much memory to allocate. So for that one, what we can do is create something like R of 4. In all these cases, these square brackets are put empty, so nothing is written inside this. But here what we are doing, int R of 4 means what? An array of 4 locations. 4 locations should be created, and those locations should be able to store integer values. So with this what happens? R is an array of 4 integer locations, and we have not specified any values in this. Right? We have not specified any values for this array. In this case, what happens? It will contain some garbage values. We don't know what values will be stored in this. So this will contain some garbage, and garbage. But never will have an empty elements. We never have empty elements, because if we create a variable, what happens? It will have some value. That will we have given the values, or system might have given the values. So if system has given the values, we don't know what those values, because those are not known to us. We call them waste values, garbage values. Right? Then, similar to this, if I create something like this, int s of 4 equal to some values I given, something like 10, 20, 30, 40. With this, what happens? I am creating an array of 4 locations, and those values, the actual values to be stored, are mentioned here. With this, what happens? 10, 20, 30, 40 will be stored in the array. So this S will be having something like, S is an array, values 10, 20, 30, 40. This is what gets stored inside. Is this okay? No. We understand what is array, what is a normal variable. Just differentiate between normal variable and array variable. So S is an array of 4 integers. This is what happens. Now, we just will take a small program and just check the values, how it will be used. Something like array, how we access the individual elements of the array or something like that. Suppose you are creating something like this, main int a of 5 is, I am giving some values, right? With this, what happens? An array is created with 5 locations, and those 5 locations, those 5 locations will be filled with these values. So the actual memory allocation will be, A is an array of 5 elements and having 10, 20, 30, 40 and 50. Now I want to print the values. Suppose A has some values, like 5 values. I want to print them. Suppose if I try to print something like, because these are integers, I can use %d in the printf. Like I am writing printf %d A. With this, what happens? Which value will be printed? All the values, first value, last value, which one will be printed? Here, one thing is showing you are giving only one %d symbol. It means only one value will be printed. That's for sure. And which value? This is the first value, last value, or average, sum, which one? Means none of these values will be printed, but something will be printed, because we will discuss it later what exactly this means. But A holds what? A is an array, and when you try to refer an array name, it will give us array address. So what is address? Those things we will discuss in the pointers concept later. Leave this one. So this will give a value, but that value is none of these 5 values. So what actually printed with this statement is address of the array. For now it is garbage value. For now it is garbage value. With this garbage value will be printed. But what I want is, I want this third value, 10, 20, 30, 40, 50. This is third value. So if I want to print third value, what I should use is print %d a of what we want? We want third value. When you want third value, you mention 2 here because the location numbers start from 0 but not from 1. See, this 10 is at 0th location of the array, 20 is at first location of the array, this 30 is at second location of the array, and this is third and fourth locations. So the location numbers start from 0 and location number of last element will be n minus 1, where n is the size of the array. Because this array has 5 elements, the location value this location value of the last element will be 4 because 5 minus 1. So if you say a of 2, what we will get is a of 2, the second element of the array A. Second element of the array is 30. Suppose if you go with a of 0 plus a of 3. With this happens, a of 0 means 10, a of 3 means 40. 10 plus 40 will get 50. Straightforward. Like normal variables, we can add elements of an array, no problem with that. And then you just go with %d. Suppose you are saying a of 1 plus 2. With this, what happens? A of 1 plus 2. So this expression is calculated first. 1 plus 2 is 3. So this expression will be treated as a of 3. A of 3 is what? Again 40. Instead, if you say a of 1 plus a of 2, in that case a of 1 plus a of 2, 20 plus 30, 50 will be treated. But here we have given 1 plus 2, something like this. And suppose if you try to printf %d a of 6. With this, do we have a sixth location in this array? No, because the actual number of locations are from 0 to 5, that is from 0 to 4. What we are trying to do is give me sixth element of the array. So is this valid? Means it's valid in C language. Suppose if you write something like this, what system will assume is, because this is the memory allocated for this array and we have more memory. Next we have some more memory for this locations. So whatever the locations we have, we just think. And similar to this, for A, you can think this side also we have other memory locations, right? What system is, when you ask for sixth element, what system will assume? 0, 1, 2, from this is the starting point for A, 0, 1, 2, 3, 4. It assumes that this is the fifth location and this is sixth location. Whatever the value available at this location, this will be printed. This will come to unprinted. So it may have some garbage, value, that garbage value will be printed. That you should understand. This is a valid statement and what system will interpret is this one. Similar to this, if you go for something like A of minus 1, if you do something like this, what happens? This is 0, 1, 0, this is minus 1, this is minus 2. So value minus 1, minus 2. The value at this location will come and be taken. So we can go beyond the array bounds, but it's not safe way because we may access garbage values. It's not much useful, and you may access maybe some other variable because we have only one array in this program, but in some other program we may have other variables also. The other variables may be stored here. Value of the other variable may come up here. If you try to modify something, a of 6 equal to some value, something like this, a of 6 equal to some 13 you have given, then what happens? This location will become 13, and if it is some other variable, some x variable is there, that value of that x variable will be modified without our notice. So these are not generally recommended, but if you know what you are doing, you can try that, no problem. So this is what happens with this is what array, how it is created, how to access individual elements of the array. Okay.